Hello, everybody. This is Derek Demeter with the Mobular Planetarium. I'm joining you this morning for me because we are partnering up with a friend of mine over in Australia. Yes, we are going to be looking at skies down under. We're going to be looking at the Southern Hemisphere, which is a unique part of the sky that, of course, we don't see here in Central Florida. We're going to be taking a look at some targets that my friend Brett will be able to show us using his telescope system in Australia. So it's going to be a really exciting virtual star prize, a little bit different than what we've been doing the last couple of months now, where we usually do Facebook Live, because of the fact that it's right now it's about 6 a.m. my time and about 9 p.m. your time. Um,
Uh,
and
yeah, 8 p.m.
9 p.m. Yeah, so we're doing a little different today because we want to make sure, obviously most of you will be. It's Friday too, so we want to make sure that we get a chance to record this and for you all to see this later on. So what we're going to be doing tonight is, this morning, or whatever time it is in your world, in the world for you. We're going to go ahead and I'm going to introduce my friend here, Brett Soames, and he's, again, in Australia near Sydney, right, Brett?
Yeah, we're about 2 hours west of Sydney.
2 hours
2 hours
west of
drive.
Sydney. All right, yeah, which is very close to our latitude relative to, but in this case, south of the equator. And Brett, do you want to talk a little bit briefly about, your setup and a little bit about yourself and stuff before we get going with our program?
Yeah, sure. I've been a sort of amateur astronomer for a while, and I have more of an interest in the technical side of things. So we actually build observatories down here, which we don't tend to advertise. But we've got a site here with 3 observatories on site, which people can use. We have a lot of hosted telescopes here. But this system we're actually using today is a 16-inch Arcos, which is a nice American-made telescope. And it works really well. It's on a Paramount ME mount. I think for tonight, it's going to work really well for us.
Fantastic. Yeah.
Except for the weather.
Yeah, well,
Except for the
you said it's pretty chilly out there, and you actually gave me the temperature in Kelvin. You said it was 279 Kelvin right now.
yeah.
All
Well,
right.
it's cold. I mean, it's cold for Florida. I
Oh
don't know.
yeah,
Maybe if you're from Fairbanks, Alaska, then you'd probably still be happy to go to the beach and be wearing flip flops.
exactly. Yeah. So we're gonna leave it there. So for those that are watching, um, you know, if you know anything about temperature conversion, that's your homework. See if you can convert 279 Kelvin to either Fahrenheit or Celsius, whatever temperature you use. And by the way, I want to let you all know that since, again, we're not doing this as a live recording, if you have any questions while you're watching this video, if you have any questions, leave a comment. Either if you're watching this on our link that we posted on Facebook or on YouTube, just leave a comment down, and we'll do our best to answer those questions from you. So we'll try to keep this. I know it's always fun to do this live and see people's responses and questions they have. That's actually one of my favorite parts of doing these things. But since we're not able to do that this go around, we'll be able to do our best to answer the comments as they come in, either through Facebook or YouTube. So Brett, what I'm going to do here is just, if you want to start kind of getting some stuff ready, I'm going to go and I'm going to share our audience a little bit about the night sky seen in your location, and kind of a little bit of why we see a different part of the sky, and kind of go over some of the constellations that we would see. So I'm going to go ahead and share my screen. And we're going to be using Stellarium, which is our program we normally use when we do night sky programs for our star parties. So I have, right now I'm going to zoom out a little bit here, and you'll see that the sky looks a little bit different. If you're accustomed to the sky here in Central Florida, you probably notice that the sky looks a little bit different than it does here. And that's because, well, we're south of the equator. And imagine the stars in our sky basically being surrounding us in almost like a globe. We call it the celestial globe, and different, imagine little pinpoints on that globe represent different stars. And where Brett's located in Australia is further south of the equator, and so he's going to see different stars than we would see in Central Florida. The other thing that Brett, which I'm really jealous of, is just how high the Milky Way is in this location. You can see that the Milky Way band, which again is our band of our galaxy, in this time of the year, we see the central regions of our galaxy. We can see that we have a much more prominent Milky Way galaxy from the southern hemisphere, and the Milky Way is actually higher in the sky than it is here. So, but another thing you're going to notice is that this part of the sky, which is what we call the Sagittarius side of the Milky Way, is visible here in Florida. But one of the areas that we do not see from this location is this part here, kind of towards the Carina and you know, what we call the Argo Navas of the Milky Way. One of the more famous parts of the Milky Way here is called the coal sack, which we'll talk about a little bit later on. But the other thing that you might notice here, if you look towards the horizon in the south, is you're going to see these two bright kind of smudges of light. And from places in the southern hemisphere in the very extreme low latitudes in the northern hemisphere, these are called the Magellanic Clouds. And this is the Large Magellanic Cloud. And these both are satellite galaxies of the Milky Way. So believe it or not, imagine, you know, these galaxies kind of like the moon galaxies of our our galaxy. They actually are being pulled in and manipulated by our galaxy. So our galaxy is pretty large. And this is the Large Magellanic Cloud. This is this galaxy is actually being ripped apart by our galaxy, and it's become a very irregular shape to it. But if you had a pair of binoculars, this would be a great target to get. So if you ever find yourself down in the southern hemisphere, whether it be Australia, New Zealand, South America, parts of Africa, you know, you will see the or the Large Magellanic Cloud, and located in the Large Magellanic Cloud is this really cool object here called the Tarantula Nebula. It's almost like another Orion Nebula. It's a large star-forming region in the Large Magellanic Clouds. So, but that's one of those there. And we also have next to it, of course, this is the Large Magellanic Cloud. Just next to it, we have the Small Magellanic Cloud. This is another irregular galaxy, our satellite galaxy of the Milky Way. It's a little bit smaller than the Large Magellanic Cloud, but it still has a very defined shape to it. This one has been really torn apart comparatively to the Large Magellanic Cloud. So again, two interesting targets to look at that we don't see from our location here in Central Florida. So again, if you find yourself located down south of the equator, you definitely want to take a look. And of course, as further south you go, if you even head even further south than where Brett is, and you start kind of heading down towards the Southern Ocean, and maybe if you really want to battle the cold, Antarctica, these Magellanic Clouds will get higher and higher and higher, and you get a much more impressive view. But actually, during their summer months, of course, right now Brett's actually in winter, and we're here in the summer in the northern hemisphere. The Magellanic Clouds get much higher as you get into the months of October, November, December, and so on. So, yeah, so definitely take a look at those if you find yourself there. But one of the more famous groups of stars that we can see in the southern hemisphere, which actually is seen on many flags in the southern hemisphere, is these four bright stars right here, these four stars. And this is called the Southern Cross. So I'm going to go ahead and turn on the names of the constellations. I'm going to bring up the lines. This is called Crux. This is the Southern Cross. And Crux actually is a very unique constellation in that it is, as the sky rotates, the lower end of the cross will point over to an area known as the Sigma Octantis. There's a constellation right here called Octans. It's like octant is a navigation instrument. So a lot of the constellations down in the southern hemisphere were named based off of navigators and explorers. And octants is one of them. That would have been a tool that these explorers were using to navigate these oceans and these locations. But over in this area here, this is actually where we find the southern star, Sigma Octantis. The problem, though, is that Sigma Octantis is not visible to the naked eye. It's a very, very extremely dim star. So unlike here in the northern hemisphere, where we have this nice bright star Polaris, which we can use to polar line and all that, people down south like Brett have a little bit more of a challenge to polar align their telescope. They're going to be using the South Star instead of the North Star for polar aligning their telescope. But the Southern Cross makes it a little bit easier, because as the Southern Cross moves around the sky, it's always pointing kind of in the direction of where that southern star is. So you have to do a little bit extra work in order to find the location of the southern star, but it's located kind of over in this area of the sky here, near Octans. So again, the Southern Cross is a very famous constellation, and we're actually going to look at the central area of Crux later on in an area known as the Jewel Box cluster. It's a very pretty cluster that's seen in the Southern Hemisphere. So a really interesting thing. But one of the areas that we're going to focus on tonight is just above it. Now, we can actually see this constellation from Florida for a very brief amount of time, very brief, and it's very low on the horizon. So many of our observers usually only see this for maybe a couple hours, but then it dips back below the horizon. This right here is called Centaurus, and Centaurus Centaurus is the centaur, so half man or half human, half horse. So we can see the legs of the horse here. You can see there's the front leg and the back leg. And here we have the head and arms and hands of the human form here. Now, just next to these two bright stars here that kind of make the front leg of our centaur are two of the more famous stars in the sky, Rigel Centaurus, which is also known as Alpha Centauri. Alpha Centauri, of course, if you are into this stuff, Alpha Centauri is the closest star system to our own here in the Milky Way galaxy, and it's about 4.25 light years away, so it's actually very, very close. It's actually technically Alpha Centauri is a little bit further away. The star Proxima Centauri, which is a star that orbits around Alpha Centauri, is actually a little bit closer to us. But that is a very, very famous star, and you can see that in kind of the front leg of Centaurus. And next to it is Hadar, and Hadar is Beta Centauri, and again, another very beautiful, bright star in the sky. But we're going to look at several objects in Centaurus. We're going to be looking at a very active galaxy called Centaurus A, and we're going to be looking at one of the largest, actually the largest globular cluster in the sky, Omega Centauri, a little bit later on. Well, I'll go ahead and when we get to the view of the telescope, I'm going to go ahead and share you all the locations of those targets there. Now, just below Crux here, we can see that there is this little, almost looks like a paper airplane I see. This is called Musca the Fly, and Musca, I can kind of see a fly shape here. That's its head and its wings there. Actually, I can turn on the pictures here so you can see. There's our centaur. There's the cross. There's the fly here. But as you can see, as you get kind of further down into the southern hemisphere, you can see that there are some constellations that are very indicative to the southern hemisphere. For example, down here near the horizon, we have Tucana, the toucan. And that makes sense. You see toucans down in the in South America and Central America, of course, where these explorers were heading down. We have chameleons, the chameleon here, volans, the flying fish. So that's, of course, if you're out at sea, you would be seeing a lot of those. Mensa, the table, right here. So we got some really interesting Pavo, the peacock, right here. You got some really interesting constellations in this part of the sky here. So, but of course, the more famous ones are located right here. Crux the cross, Musca the fly. And what's really cool about the Southern Hemisphere is we have this really gargantuan, this large group of constellations here called the Argo Navas. And if you are familiar with Greek mythology, this is the ship that Jason and the Argonauts sailed on. And of course, if you're a sailor, you would obviously be inspired by these early explorers like Jason and the Argonauts. And the astronomical community decided that because of how large this part of the sky was, they decided to break it up into 3 distinct constellations. We have Vela, the sail, which is located right here. We have Pupus, which is my favorite, Pupus, the poop deck, which is the front of the boat. And we have Carina, the keel, or the stern, or the back of the boat here. And located in Carina is a really cool target that unfortunately is a little too large for Brett's telescope, because this telescope is very large, called Eta Carina. And Eta Carina is this massive star that's basically just falling apart. It's shedding. It's becoming extremely unstable, and it's releasing all of this gas into space. And it's said that eventually Eta Carina is going to explode with such power. We call these massive stars that explode with such great violence called hypernovas. And so this is something that we have to keep in track of. But the Eta Carina is a great object to look at with a wide field telescope. If you want to bring a telescope down to Australia and you don't have the time to bring a giant telescope, having a pair of binoculars, or even a smaller telescope, you'll be able to see Eta Carina with great detail. So that's kind of a little bit of an introduction to the Southern Hemisphere. Of course, what's really weird is, which is not weird to Brett, weird to us in the Northern Hemisphere, is that again the south, the circumpolar is actually in the south, and in the north is what we would see in our southern sky. And what's really interesting is that they can still see some of the constellations found in our sky. For example, you can see there's Boötes. We talked about Boötes in one of our star parties. They can still see Virgo, Ophiuchus, Aquila, Hercules, Leo, Scorpius, Libra. So a lot of the constellations that we can see here in the Northern Hemisphere, they can see as well. But of course, they're fortunate that they also get a whole new part of the sky, specifically down towards the southern part of the sky, that we don't see here in the Northern Hemisphere. The other thing that I'm a little jealous of is that being closer to the galactic core of the Milky Way and the ecliptic, the path that the planets and the sun move in the sky is higher. So the planets actually are nice and high in the Southern Hemisphere. So it makes for really great planetary viewing as well. But all right, so that's kind of a little bit of a view of the sky. What we can see, as I said, I'll zoom back in here once we get into our targets. So I'm going to go ahead and stop sharing my screen here. And Brett, let's see what we can see in the Southern Hemisphere. So do you want to talk a little bit about your setup that you have in the observatory?
This particular telescope?
Yeah, telescope or the observer, just kind of, you say, as far as, some of the tools you use for taking images and different things like that.
Okay, so we use a whole bunch of different software, and it depends on the actual equipment we're using. We have some systems here that are completely automated, so to the point where you can actually select a target, type it in, and it will schedule it, take it for you, and you get your data emailed to you. I mean, that's one that's really, really easy to use. The system we're using tonight, it's quite manual still. We have automation software that can control it for the night, but you have to have a look at it, what it's doing each day. And unfortunately, at this time of year in this observatory, we're getting a lot of humidity, which is a bit unusual for this area, and starting to come in about 12 o'clock at night. So that's a bit of a problem. That's something you have to work around. But this observatory right now is roughly 10 meters, so 30 feet by 15 feet wide, and we've got about 10 telescopes in here. in this one.
10 telescopes. I'm jealous. That's a nice collection there.
Yeah, it's nice to be able to choose. As you may have mentioned in the past, telescopes don't zoom generally. So if you want to take, and as you mentioned before, we're going to have a look at Eta Carina, but unfortunately this telescope, because it's quite large, has a long focal length, which means it has really high magnification. So that's really good for galaxies, but with something that's really large like Eta Carina, it's a bit of a problem because we just don't get the whole image in there. We will have I guess we can scoot over there and have a quick look at that and zoom in the actual star of Eta Carina.
That'd be great. Let's do that. Yeah.
Okay, well, I'll share my screen with you guys. So I'm going to actually share exactly what you see. Nope, and
there we go.
Righto. Fantastic. So MaximDL is our program that we're using over here. That's for camera capture, but we're using, this is kind of like Stellarium, like Derek showed just before, but the mount we're using requires us to use this particular piece of software. It's pretty nice anyway, so that's not really a problem. So this is called the Sky. So we are going to...
Yeah, and our telescope operator and good friend Frank Kane, who works with us at these star parties, uses SkyX as well. So I know a lot of our seasoned viewers have seen some of the tools that Frank uses as well. So they might be a little bit they're like, oh yeah, that's the same program that Frank uses. So they're at least a little accustomed to the SkyX at this point.
Yeah. So he has a MIT, a Paramount MIT.
That's correct. Yeah, he has a Mighty mount and a 190 millimeter Mac Newtonian, which is a great telescope. But and it's really impressive what we've been able to view using that telescope.
Yeah, they're an underrated bit of kit. I remember seeing some of your images years ago.
Yeah, they're yeah, exactly. And I'm just going to be releasing some of my images on that, and did some observing the other day, and it is a very, very nice setup. Of course, I'm a little envious with focal length for galaxies and planetary nebulas and stuff where they're just too small, but it makes for a really great wide field telescope.
It's a nice flat field, and that's what a lot of astrophotographers, when they first start out, they kind of get a bit surprised when they take an image and you get an aberration out towards the edges, which takes some fixing or get a fancy telescope to take care of that. But that, although it's a fairly inexpensive telescope, it performs really well.
It does, yeah, exactly. Yeah, so you know it's a great quality telescope, but the downfall is you're limited on focal length. So you do have so unfortunately some of these smaller galaxies and things like that are just a little bit more difficult to see.
So,
all right.
So that is Eta Carina. So I'm probably going to get a little bit technical here, but this is actually a scientific grade camera. So and that's what that artifact is in the middle. So that's an extremely bright star that Derek was talking about that's going to go hypernova. There's actually a small nebula around that called the Homunculus Nebula, where it's shedded its outer layers in the past. Because at one stage, I think last century, this was the brightest star in the sky.
It was, yeah.
Memory. So as it's blowing its outer layers out, as it's getting old, it's a massive star. And you can see all the nebula starting to form around there. If I can bump up that, let's stretch this a little bit more. Let's see if we can get some more of that nebula. Yeah, that looks better.
Yeah. Oh, yeah. Yep.
So unfortunately, this field of view isn't quite big enough to get the keyhole, but you can see some of that nebulosity coming around. Just put this over.
Hey, it's just it's a treat for me to see it, you know, being from, we don't get to see that from this location.
Yeah, well, next time we'll have to use the RASA. It's ideal for this system. This is really a galaxy killer combo, and you know it's science grade camera. So it is only in black and white, but that artifact is actually caused by most cameras will start to fade off some of the signal when they start to fill up. This one doesn't. So when scientists can read the value of a pixel, it's actually a true reflected value in that pixel, and actually linearly rather than what curve would you call that from a standard anti-blooming camera or a non-anti-blooming gate camera?
Yeah. Well, I'm not quite sure what I don't know the technical name of it.
Sorry. But yeah, that around that area, you can just see the dark lane starting over here. I don't know whether you can see my...
Yeah, a little bit. Yeah, I can see a little bit there. Is there a way we can get a little bit extra exposure time on it, or?
Yeah, we can go up to say 1:30.
Yeah, that sounds good.
I'll just turn off, because that was calibrated. So I'll just turn that off. But we are going to get that bloom through the center. Would probably go top to bottom.
Right.
It'll get much worse. So it's off and running. We'll do a 1:30.
Yeah. So while we're waiting, so Eta Carina, expected to go any moment, and who knows? And it's one of those things where, just like we have Betelgeuse, we talk about Betelgeuse a lot in the Northern Hemisphere because it's Orion is so prominent here, that, Eta Carina is kind of the southern component of Betelgeuse, but it's even more, it could be more violent. But I'm trying to remember the distance of Eta Carina. Do you happen to know that on the top of your head, Brett? The distance of it?
No, there's been a lot of conjecture in the last few years about Eta Carina. They think it may be actually a binary. There's a lot of talk, but it's very difficult to study because of the Homunculus Nebula around it. There's
Right.
an absolutely beautiful Hubble shot. If people can just go and Google that Hubble shot of the Homunculus Nebula, it's amazing.
You keep using this word homunculus. Can you talk a little bit about what that word means? For those that might not know what the word homunculus is. It's a very fun word to say, for sure.
It's a very difficult word to say, and I wish I was smart enough to be able to tell you what that means.
Yeah, so they're like pillars. There's plumes of gas, pillars of gas, if you will. But like a cloud, a lot of these plumes of gas kind of obscure, like our various views of and other nebulas have this as well. The Rosette has it. The Lagoon Nebula has it. So, but Eta Carina definitely has a very prominent amount there. That's looking pretty good. I like that so far. Yeah, nice and bright there.
We really need to have about 4 times the size of this field of view to really do the nebula justice around it, because it extends for quite a ways out. And there's some lovely colors in it too. There's lots of oxygen, of the blue, and lots of hydrogen. So you get the pink, red tones. And even looking through a telescope, you can see a lot of nebulosity. It sort of compares almost like M42 in Orion.
Exactly. Yeah.
What you can see.
Now there are people that go down to the Florida Keys, and there are very few times of the year where you can see Eta Carina just on the horizon. But observing on the horizon is not ideal. But a lot of people like to brag that they got a chance to see the Eta Carina, and also the Southern Cross can also be seen near the horizon as well at certain times of the year here in Florida. So there are places you can go if you're watching and you're in Florida. You can actually go down to the Florida Keys, usually around the months of April and May, March, April, and May, and you can see the Southern Cross for a very, very small, brief period of time near the southern horizon. So yeah, so Eta Carina, yeah, I mean, so hopefully we can do another one of these where we can use the RASA and we can get a better view of Eta Carina. But of course, as you said earlier, this thing kills it on galaxies, and there's some really cool galaxies up right now, particularly in the constellation of Centaurus, and one of the more famous galaxies in that is Centaurus A. I think that'd be a great target to look at. And while you're getting that set up, Brett, I'm going to go ahead and steal the screen share, and I'm going to go ahead and show everybody where they can find Centaurus A in the sky. So right now, as you can see here, we are looking towards Centaurus here. Again, there's Alpha and Beta Centauri. And what we're going to do is we're going to look, I'm going to go ahead and, there we go. Let's see if I can, Centaurus. Oh, I hit the wrong button. There we go. That's what happens when you're doing this at 5 in the morning, or 6 in the morning. Turn that off there. So Centaurus A is kind of in the shoulder, just below the shoulders of Centaurus here. So there's his head, kind of there's his shoulders. So it's kind of his right shoulder, just below it. We can see as we zoom in here, this really pretty galaxy here. And hopefully what we're going to be able to do is we're going to be able to see these dark lanes. And this galaxy is kind of a weird galaxy. It has a very regular shape. But it's very, very active. It has these huge jets that come off of the galactic core. It's actually one of the most active galaxies. We call them active radio galaxies in the universe. So, and it's been one of the first ones to be observed this way, and it's still observed, and it's a great way for us to learn about how these very powerful galaxies are behaving. So again, Centaurus A is a great object to look at. So I'm going to go ahead and stop sharing my screen here. And Brett, when you're ready to show off Centaurus A, we'll take a look at it. So
okay, so I've taken the liberty of starting an exposure. I ran it for 5 minutes.
Okay.
Just to get a nice.
Yeah. Well, while we're waiting, do you want to talk about kind of its discovery? Because it actually has a connection to Australia with Centaurus A.
So, as you mentioned before, now I'm a bit patchy on the history. So I believe it was discovered by the Parkes Radio Telescope. I don't know whether you've seen the movie The Dish. It's a small budget Australian film which dealt with the Apollo landings. And they captured the images that were downloaded of Neil Armstrong landing on the moon. So they actually came down through the Parkes Radio Telescope. But they found this as a radio source and correlated it to the optical element of the optical wavelength. So the Parkes Radio Telescope I've actually been there and worked on the telescope, not on the radio side of things. I'm actually a garage door repairman, and I've worked on their systems there as part of the tilting mechanism of it. And they just found it as an extremely bright radio source. And even if you have a look, there's a lovely image. It was similar to the one you showed, but it actually has some lobes, I think, in another band up in I think it might be in X-rays.
Yes.
So, yeah, Centaurus A, it's beautiful on so many levels. Looking through it with a telescope, it's very, very faint. It's got very low surface brightness. So you can see it's got a nickname, the Hamburger Galaxy, and that's what it actually looks like through a telescope, even a large aperture telescope.
You know what's interesting? It's interesting. There's like 3 or 4 Hamburger galaxies. There's of course the more famous Hamburger galaxy in the Leo triplet, but yeah, they all kind of have their version of that, right? Everybody has their version of the Hamburger galaxy.
So it's so incredible that it looks at so many different wavelengths of radiation. So in the optical, it looks like that picture you just showed. That picture you took was quite a deep shot where the center glow had gone out quite a ways, and that takes a bit. I've done a couple of exposures of that, and I've done over 10 hours of exposure, and that's just starting to come out there. But then you look at the other wavelengths, you've got the radio, and then you have, I think it's in the X-rays, the lobes look incredible.
Yeah, those very active these bursts of jets, and we're not quite there's quite mysterious still. and trying to understand how that works. And there's even been observations in the gamma ray wavelengths. And so this is a very really cool galaxy, and you'll see that it has a peculiar shape, but technically it's defined as, I believe, a spiral galaxy, if I'm not mistaken, or was or is very similar to a spiral galaxy. But what gives it its shape and its is thought to be from a massive galaxy collision a long time ago, and this galaxy collision actually distorted the shape of Centaurus A and has given it its view. But also the dust, there's a lot of dust found in this galaxy, which gives its shape as well, and it's distorting the view of the galaxy. So it's a really interesting a galaxy to look at. It has a lot of star formation. We see that a lot near the dusty lanes of the galaxy. A very active, a powerful galaxy emanating these very, very high level of jets in the X-ray and gamma rays, and it's a great target, and it's a great thing to look at. Now, we actually can see Centaurus A for a brief period of time here in Florida as well, but again, it's only up for just a few hours, and it's very, very low to our horizon, so it's not the greatest galaxy for us to observe. So being able to see this from your point of view, being very high up in the sky right now, will be a huge treat to see. So there it is.
So another really interesting part about this galaxy, and a lot of amateur astronomers there's a blue jet that comes out of the side of the galaxy. It's quite faint, and it's very difficult to get. Obviously, it's not showing on here because this camera that we're using is a black and white camera, but we'd have to go and take a lot of exposure to get that part. So it's just so interesting to learn about this particular galaxy, because there's so much and more to be learned about it. It's the galaxy that just keeps on giving as far as knowledge is.
Keeps on giving, exactly. And so you can see now, we can see those really prominent dust lanes, giving that what we call the hamburger look to it. And those dust lanes give us a clue to how that galaxy has evolved. Again, probably a more defined shape at one time, but because it collided with another galaxy, we have this very irregular shape to it. We can see all this dust was redistributed or along the galaxy, and now we have these really nice dark, patchy, dusty areas. But again, if we were able to look at this in color, you would see reds surrounding those dusty areas. Again, that red would suggest of large areas of star formation. And as Brett said, you'd be able to see those bluish jets that are coming off of the it's kind of the core of this galaxy here. So a really treat to see Centaurus A in such detail. Again, it's a challenging target to get from here in our latitude, but probably a pretty simple one from where you are, Brett.
Yeah, it's almost straight up.
It's almost straight up. Yeah, that's pretty crazy. And of course, we were talking about this in one of our episodes of the Virtual Star Party. We were talking about weather and seeing and transparency. And of course, the higher an object is in the sky, the more transparency, the less atmosphere you have to fight with, so you get much greater detail. How is your seeing in your part of Australia?
It's actually, this particular site is really good. Tonight is not, unfortunately, because our humidity is quite high, and we still have some high cirrus.
Yeah.
So it's not ideal. I'm just looking up right now as we say that the clouds are clearing out a little bit. We're still seeing some towards the horizon, but I can still see the high cirrus, and that's going to be knocking around. We do get quite good seeing here, but unfortunately not tonight. But for what we're doing, it'll work really well.
Exactly. That's one nice thing about doing these virtual events, is that you don't have to you're not doing serious astrophotography. People, we can see some of the things that we would normally want to see during these events. So we've talked about Centaurus A galaxy scene, a very, 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 very unique and very prominent galaxy for research. There's another target in Centaurus that's really interesting. It is a large globular cluster, or some astronomers will even say that it could be very likely remnant of a dwarf galaxy because of just how different this cluster is comparatively to other globular clusters. You know, here in the Northern Hemisphere, we have the Hercules cluster, M13, we have M3, we have M15, we have M22. But Omega Centauri is, I think, the king or the lord of all the globular clusters. And while you're getting that set up, I'm going to go ahead and start. I'm going to share Stellarium again, and we're going to go ahead and take. And so right now we're already here in Centaurus. And what's really interesting is that back in the day, this object is so bright that the ancients actually saw this as a star, which gave the name Omega Centauri. You know, so that's what made this this star this globular cluster so unique, is the fact that, again, it has this and unfortunately it's really, really bright, but we'll be able to see that cluster of stars there. It's given it such a unique name, Omega Centauri, unlike the other globular clusters which were discovered by telescopes. This was actually seen by people with their naked eye, but of course, as I said before, they didn't see it as a cluster of stars. They saw it as one star from their naked eye view. But when telescopes were eventually used on this object, we were delighted to see that this thing was just millions upon millions upon millions of stars. It's a truly incredible sight to see. And again, being that it's so high up in the sky for Brett, and normally it would just be just right above the horizon. Actually, I do have an image of Omega Centauri I can show here as well while we're waiting for the image. Actually, this is a target that we've been able to get here in from our place in. But again, it is really challenging. It is tough for us. Again, only a few hours of the year where you get to see this object. So let's see here. I'm trying to find it here. Oh, that's the wrong one. That's the wrong folder. I got too many folders. Too many astrophotos. You know, you start realizing, man, I have a lot of folders of astro photographs, which is good. It means that we're doing what we can.
So we're ready to go.
Yeah, I was gonna quickly. There we go. I'm looking for the. There we go. There's the image. So I'm gonna go ahead and share this image real quick, and then we'll go ahead and take a look at your view, Brett. So this is a view of an image of Omega Centauri from a view from my Mac Newtonian. And this is a final process image, but you can see this is just a massive star cluster, globular cluster. Again, millions, hundreds of millions of stars. And you can see that most of these stars are blue, or not blue, but orange. They're actually very old stars and very, very metal-rich stars. And I just wanted to show, because we're looking in black and white in your image, Brett, but I wanted to show that this is a star cluster with a lot of kind of orangish stars, a few blue stars here and there, but a kind of an old star cluster. So yeah, let's go ahead and see your view now. Let's see what we got with your view of Omega Centauri.
So I really like that image of yours. You really showed the colors there. And those stragglers actually look absolutely amazing. There we go.
There it is, in real time.
So, yeah. So this telescope, again, is probably a little bit too much magnification for this object, but I would say it's probably the best object I've looked at through a telescope.
Oh,
it is just, it's mind-blowing because every one of those dots is a massive star. So it actually, when you look through a telescope, it isn't defined as what we get when we look through the telescope. It actually looks very smooth as it goes out towards the edges. But, you know, every one of those is a sun. And it's kind of humbling. You can't be arrogant when you're looking at that. You just go, wow.
Yeah, tens of millions of stars and 4 million solar masses. I mean, this is a huge cluster of stars. Again, it's considered a globular cluster. Of course, these globular clusters sit in this halo surrounding our Milky Way. But again, what's really interesting is it doesn't. It's kind of in a weird position for a globular. We find these globular clusters kind of in this halo, but Omega Centauri kind of sits in a very unique location. But what's really interesting is that unlike the other globular clusters, the stars found in here are different in a way. They have different ranges of stellar ages. Usually globular clusters, the stars have formed around the same time. They're usually around the same ages. But when we look at the absorption lines or the spectra, the colors of these stars, and we look at we find out that the stars have different what we call metallicities, basically the amount of metals and other things that are found in the star, how impure the star is. Most stars are made of hydrogen gas. But these stars actually have some impurities, what makes them look red, orangey. They're burning denser material in their cores. They're not as hot. They're not burning pure hydrogen anymore. And what's interesting is that some astronomers think that if this thing has stars of different ages, then that suggests that maybe this was a core of a dwarf galaxy opposed to a globular cluster. So there is some debate going on right now of, do we consider Omega Centauri a globular cluster or not a globular cluster? The other thing is that there were views of Omega Centauri thought to have potentially a central black hole, but that's with observations with the Gemini telescope observatory in Chile, found out that it doesn't have the what we call radial velocity, the amount of speed that those stars are turning near the core. They're not actually turning faster than the stars further away, because if there was a black hole in the center, the stars closer to the black hole would be moving around that. They'll be moving faster than the stars further away. But that we have actually found that that's not really the case. So, but it could very likely have been what we can consider a dwarf galaxy, similar to kind of like the Magellanic Clouds. That had been and that's been absorbed by our Milky Way. So it's kind of pretty cool to think that astronomy is always changing, it's always evolving. As we're taking more observations, we're starting to see and learn some new things. It's really cool. And like what Brett said, looking at Omega Centauri through a telescope is just amazing. And what was the view of what size telescope was it that you viewed Omega Centauri for the first time, Brett?
Look, the first time was in a 4-inch refractor, but I think one of the best views. Well, I mean, it's bright. So what a lot of people don't understand, what I'm sure a lot of your listeners would know, is a telescope is more of a light collector. So if it's a bright object, it's generally pretty easy to see. And Omega Centauri is quite bright, so you just don't need a big telescope to look through it. But when you do, holy cow!
Yeah,
I've looked through it on a 24-inch, and what was really nice about that is with the smaller telescope, it looks incredibly smooth and it's not defined. It almost looks like a cloud. But when you look at it through a really large telescope, you get to resolve the individual stars. You get to see that mottled appearance, like you see in that image there, and that's really nice. So, I mean, if you can look through a big telescope at Omega Centaurus, push people off the ladder. Just get to that telescope.
Yes, definitely. So that's definitely a target you want to look at. You want to plan if you ever find yourself down in Australia or other parts of the Southern Hemisphere where Omega Centauri is nice and high. Definitely. And I was in Chile a couple of years ago, and I got a chance to look at Omega Centauri through a 16-inch Cassegrain, and oh my gosh, what what an incredible view that was to see that in great detail. So definitely Brett is not kidding. It is a truly remarkable thing to see. So Brett, what else? So we got a couple of other objects we can look at tonight, right? We have we talked about we talked about a globular cluster. There's another galaxy in Centaurus too that you really like. It's I believe NGC 4945, I believe, yeah, which
Yeah.
is
Okay.
another
We'll go and take a
incredible
look at that.
galaxy. And when I look at this galaxy, I see it. It looks a lot like the Whale Galaxy that we see in Ursa near the Ursa Major part of the sky here in the northern hemisphere. So I kind of call it the Southern Whale. If we have the Northern Whale, this is like the Southern Whale. That's the way I see it, anyways. But again, this is a barred spiral galaxy. It's actually part of the M80 group 83 Centaurus A group of galaxies. So what we talked about in one of our previous episodes is that galaxies are mostly found in these groups. We have the M86 group, we have the M81 group, we have the local group, which is where we live. And this one in particular is in the M83 Centaurus A group. It's actually the brightest of these galaxies. And again, it doesn't really have a name, unfortunately. At least not that I know of. Do you have a name for it, Brett, or is there a name that you all have down in Australia for this galaxy? Because you call the other one.
No, just 4945.
No, it's
We kind
interesting.
of know it.
It's interesting. It's three
It's
galaxies. Oh, sorry.
okay. So you go. I'll jump in after.
Oh, I was just gonna say, it's so funny that this galaxy is very bright, and you think that somebody would have called it something, but yeah.
It's an unusual one to photograph, and I don't understand why. I don't actually know much about 4945, but it's a really difficult one to. I know you said it was bright earlier, but it seems to be not so bright when you take, because it's edge on, so you're not seeing the spiral that you do, that classical galaxy look.
Right.
So you're looking at it from the edge, but you do get to see some variation in the colors. It's quite a brownish color, which is quite unusual. So processing an image that you've made of NGC 4945, I've never got an image that I've really liked of it, but it is a nice looking object to see. Now, obviously we won't see the browns because we're using a black and white camera, but it's just nice to get a perspective, because when you think of a spiral galaxy, you're thinking of that traditional spiral, but we're looking at it from the edge.
Right. Yeah, no, that's why I thought it's kind of reminded me of the Whale Galaxy, because it's on that kind of edge view of the view here. Again, seeing those nice dark dust lanes, and again filled with star formation as well, which is very common with barred spiral galaxies. Hopefully we'll get a nice view of this here very soon. We're doing 200 seconds, so it'll be up in a few more moments here. What if you had so Brett, being from the Southern Hemisphere while we're waiting for this, what's your favorite galaxy to photograph?
Oh, M83.
M83?
Oh, by a long shot.
Well, I think we should look at M83 then.
Yeah, we can go and have a look at that next. NGC 55 is really nice as well. That's one of my other favorites. And NGC 253. But can you get that from the Northern Hemisphere where you are?
Yeah. We can get M83, but again, it's also a very low galaxy. M83 is near Hydra, so that's pretty low in the sky for us. But so I always find it incredible. I know that Frank's, unfortunately, he says it's too low for him where he is. So being able to look at this would be a treat as well to get this. So I think that should be our next target here. I was thinking of another galaxy that are you able to actually no, that would not work. I just realized that's a pretty small galaxy relative, but I didn't know if you could get the Circinus galaxy at all from that location, but I thought that's probably pretty small, even for your telescope, I'd imagine.
I don't know it very well, that object.
Yeah, it's another active galaxy, and it's just below the galactic plane, kind of. And I thought, well, that might be kind of an interesting target, but it might be a little more challenging.
Should we run an experiment?
We should. Why not? Right now, I don't know what the designation of the. I don't think it has a designation, NGC designation. Let's see. I'm looking it up right now. See if it has a designation there. All right. Yeah, no, it doesn't even have an NGC designation.
Sometimes SkyX will pick up even without an NGC number, just from a common name.
All right. Well, there we go. There we have the target. Well, actually, it's looking. It was actually. Let's take a look at the galaxy a little bit more here. I think unfortunately it was. Is it showing up? The Circinus galaxy.
Yeah.
Okay. All right. We might have to give that a go.
Experiment on the fly. It's not an object. It's not an object I've shot. So should we go for a longer exposure or?
Yeah, let's see. Let's try it. Yeah, let's try 200 seconds. Let's see if that works.
Well, I might run it up to bin 3 because I'm a little bit oversampled. So let's try.
And while we're waiting, do you want to talk a little bit about why we use binning in taking images of objects? Because a lot of people have asked us about binning and what binning means. I know Frank has mentioned that a few times in our virtual star parties and things like that.
Yep. Okay, so I'll actually take a step back to make it understand a little bit more about cameras. So the cameras that we use, you can almost think about them as an array of solar panels. So each pixel is an individual solar panel that is getting light and converting it to electricity and storing it. So in the cameras, you have a certain amount of storage. So much electricity. And we saw that before when my camera filled up, we got that bloom in that first images we were taking. Mm-hmm. So that's called well depth. So what binning does is actually collects, instead of in an individual pixel, it grabs 4 pixels and calls them 1 pixel. So effectively, you've got a larger 4 times solar panel. So you can cameras tend to be more sensitive and you have more well depth. So if you want to take, an image, it lowers the resolution, but you gain some signal. That's basically what it is. And there's also a relationship between how much magnification or focal length your telescope is to how big your pixels are. And there's plenty of math if you want to look up arc seconds to pixel around that. Right. And that can also be matched to, how still your sky is, how good your seeing is. So our seeing is not so great tonight, although I'm telling you a lie because it's actually looking pretty good now.
Yeah, the stars look pretty nice in that image there of the 4945.
Yeah, it's really starting to clear up. We've started hardly any cloud at all anymore. So yeah, binning is basically collecting, instead of a single pixel, you're grabbing 4 times the amount, 4 pixels, and calling that 1 pixel. So this camera is a 6 megapixel, so you divide that by 4, and that's the megapixels of the camera now. So the trade-off is you're trading resolution for sensitivity in the camera. So I'm really excited. I'm not sure what we're going to get here.
Yeah, this galaxy is really interesting because it's part of this thing called the Council of Giants, which are these large galaxies that surround our local group of galaxies, and it's only, I think, 14 million light years away from us. So it's actually a very close by galaxy, and it is ripping. It has this huge amount of active outbursts of gas in the galaxy. It's a really interesting object. So. And we don't really see this object at all from our location. So this will be really, really nice to see if we can get this target. I'm keeping my fingers crossed. We can get this. So this will be great for you, Brett, because this is a new object you haven't looked at. So
yeah, absolutely. So it's very small.
Yeah, it is very.
Oh wow.
Very small, yeah, but there it is.
There it is. Can you see my cursor?
I can, yeah.
Yeah, that's it, just there.
That's it, yep. And it's so weird because this galaxy is so close to us, but it's, it's just,
So to give some scale, people often say to me, how much zoom does your telescope have, or magnification? And I try and compare it to a telephoto lens. When you see those big telephoto lenses that paparazzi or wildlife photographers use, they're like, say, 300 millimeters, so 12 inches of focal length.
Right.
I'm metric, so you might have to do the conversion for me. But this is running at about 3,400 millimeters of focal length. So, 10 times the amount of zoom, and it's still that small. So.
Yeah, so that's
a small object.
It's a small galaxy relative, even though it's kind of it's called as part of this Council of Giants. It's actually a very small galaxy compared to, say, our galaxy or the Andromeda galaxy. But it is a very peculiar galaxy, but it's still kind of neat to be able to see that. Are you able to stretch that a little bit? Maybe we can get a little bit more of the. And you know what? Yeah, let's zoom in as much as we can. It may not look as good from your point of view, but maybe. Oh, there we go. We're starting to see some of that detail on the outer edges there.
Yeah,
see if we can zoom in.
See a little. Yeah, starting to see a little bit of tracking error there.
Yeah, but that's okay. But you're starting to see that kind of dust lane forming. Kind of just above that the core of the galaxy there. So
yeah, you can. So I'm just up on Wikipedia. I'm having a look. So you can just see this dark area through here. That's actually dust obscuring, because that would have, as you can see, there's a glow around here. So that glow is behind there as well. But there's a dark lane cutting across from about here all the way over to here. So that's a really interesting object. But this is like really small. So this is 3 by 7 arc minutes.
So do you have a telescope that you can get a better view of that down the road? Let's say if you wanted to get a better image of that. You said
I think you'd probably want to go up to the atmosphere. Well, we have a 24-inch here right beside me, but I mean, it's not going to provide that much more detail. So when something's getting down that small, you're very limited by atmosphere at that stage.
Right, and of course, this was an image. This was a galaxy that was really studied by the Hubble Space Telescope and the Chandra Observatory. All the big telescopes above the Earth's atmosphere in high resolution. So that's, of course, it was actually discovered in 1977. So it's actually, even though it's very close to us, it wasn't really known for a while because, again, of its how small it is and how low brightness it is. So
where's that next object?
So I think we have time for one more. I think we should probably finish it off. We're going back to where we started with Crux. I think we should look at that jewel box cluster. We looked at some galaxies, looked at globular cluster. We looked at a nebula, at a carina, or a star, if you want to consider that. Let's look at a really nice open cluster. This is so, here in the Northern Hemisphere, and you guys have this as well. The Pleiades are the quintessential view of a star cluster, right? But the jewel box cluster, in my opinion, is what I would call to be the Southern Hemisphere's. It's almost like the beehive cluster in Cancer. If you were to look at on a dark night at Crux, the cross, you could almost see kind of like almost a faintish, kind of fuzzy out of focus star area in the middle, and that's this jewel box cluster. Really pretty open cluster of stars that's located in the middle of Crux. And Crux is actually, while we're waiting for this, Brett, do you have any tips? A lot of observers here in the Northern Hemisphere get really anxious. I was with a friend of mine when we went to Chile. He was very anxious on trying to polar align his telescope because he's so used to Polaris. But do you have any tips or tricks on how to polar align, in the Southern Hemisphere?
Yeah, we do it with software. So I never look through a poloscope. I mean, so sigma octans is so faint. It's unbelievably faint. You need a telescope to look through to actually see sigma octans. You can't see it by eye. So even when you're looking through a poloscope, you're kind of wasting your time. I use a program called PemPro, and the SkyX, the control software we're using as the Planetarium here, has a really nice function for modeling errors in your mount. And so that's what we use. So you guys, I mean, we've got some really nice objects down here. I so wish I had a Polaris.
Yeah, right. Yeah, and that's the thing, is that we're a little spoiled up here in the Northern Hemisphere. But again, I brought my AstroTrack down to the Southern Hemisphere to do some Milky Way photography of the night, and it was it has even markers and all that stuff, and that was even a little challenging to try to line up everything, because you had to use 4 or 5 different reference stars around octants and in that surrounding area just to kind of line up and to get Sigma Octantis as best as you can. So yeah, I could imagine that using software is really the best way of doing it, to get a true precise alignment. And there we are. So again, a nice, beautiful cluster of stars. And it's actually one of the youngest clusters of stars in the in the sky. It's comparatively to, say, other clusters, only about, I believe the age is, if I'm not mistaken, about 14 million years old, which may seem very old to us, but for star clusters like the Pleiades are over 100 million years in age. This is 14 million years. So this is a very infant open star cluster. So it formed, usually these star clusters form in these large clumps of gas, like we saw with the Orion Nebula. When we look at Orion Nebula, that's a star nursery. Eventually all that gas gets blown away by the solar winds of these stars. And what happens then is and you get these open clusters, and over time these star clusters will eventually spread out as they get older. And so this is a very nice defined cluster of stars. So I think it's just a really pretty object. And there's all these stars have blues and yellows and oranges and stuff like that.
Yeah, so this star here, which I've got my cursor on, it's such a contrast because it's a really reddish yellow star compared to the blue stars around it. And you can actually see that color in the telescope. Even a small telescope, a small 4-inch refractor looks great in that. This is one of those objects that no matter what focal length of telescope you're using, it always looks beautiful. If you have a really wide field picture of this, there's actually a lot of stuff going on around there as well. There's a lot of nebulosity, a lot of really interesting things, and it has a really nice contrast to the jewel box in the center, and the different colors is beautiful. I wish I had a color camera on this
Yeah, let me see.
telescope.
I'm actually going to look up an image of the jewel box. Let me go ahead and I'm going to share my window here. I'm going to go ahead and do that, and I'm going to show an image. Here's an image of the jewel box and color. And again, you got all these beautiful blue stars here, again, you have just this absolutely gorgeous, like deep orange star that kind of just sits by itself in this jewel box here. So quite a sight to see, and especially through a telescope there. Well, Brett, I don't know about you, but that was fun, man. I loved being able to see the skies you have down there and some of these targets that I've been wanting to look at. And I'm sure, Frank and Justin, who work with me on these star parties, are hopefully going to be able to take a look at this video later on and look through the telescope as well. But hopefully maybe we could do another one of these down the road, maybe when the skies change a little bit, and see some other interesting objects. I know I would love to see some of the objects towards the Magellanic Clouds and other targets. So, anything,
absolutely.
And we appreciate your time. And is there anything before we wrap it up here? Is there anything else that you would want to mention to our audience about what you do, or or anything like that?
Yeah, look, we do some hosting here. We call it JBL Observatory at the moment. We don't actually have a website. We've sort of been fairly quiet and under the radar, but we are opening up some of our telescopes. And this particular telescope that we've been using tonight will be able to be used by the public in the near future. So we've had sort of private people, and we've had a lot of research, like the telescope over our shoulder has been working on binary asteroid research. So we have a lot of research telescopes out of here as well. So that's something that I'm very excited about as moving forward. Next time, if we do this again, I would like to jump on the RASA, which is actually a color camera. And a lot of these images that we're taking of tonight will be actually see in real color and a wider field of view. So that should be fun.
I think I'm excited. So, Brett, yeah, we'll definitely have to coordinate another star party, and hopefully maybe I can drag Justin and Frank, get them up early so we can do it together.
Yeah, so, and maybe we can do it later so you don't have to get up at 4 o'clock in the morning.
Oh, it's all good. It's worth it. So it's definitely worth it. Well, Brett, thank you so much for your time, and we really appreciate and seeing the skies from there. And definitely, so for those that are joining us in this recording, we're going to be doing another star party next Friday, starting at 10 p.m. our time, Eastern time. And we're actually going to be talking about observing satellites and other objects that are artificial in our sky. So it's all about observing objects like the International Space Station, satellites, and talking about issues with satellites like Starlink and for astronomy. And Brett, have you seen any of the Starlink satellites yet in the sky? Have they been an issue?
No, I haven't. No, they simply haven't been.
That's good. That's good. Well, it's gonna get worse.
I've been following it. And it sounds like SpaceX really, they took it on board. I think they were shocked that this all happened. And Glenn Shotwell was saying, "Wow, we didn't expect this to happen." And the last batch that went up, but they did some experimenting on them to try and stop reflection. So, I think they're trying to help out. But the other thing that's really great about that internet connection that we'll possibly get is more remote observatories in more remote locations with good internet. So there's
a great way of thinking about it. Yeah.
There's some downsides and there's some upsides. I've actually seen some really cool pictures of them coming apart and astrophotographers taking pictures of those, which I think is pretty cool. But, it hasn't been a deal for me.
Yeah, and that's something that we're going to definitely talk more about next week. We have Emily Speck she's a local space journalist that's going to be joining us for that. But we love doing these, and we continue to do them. And I want everybody to stay safe out there and keep looking up at the sky. And with that, thank you all for visiting and joining us on this episode. And we'll see you live again next week for our next virtual star party. So good night or good day or whatever you are in the world. Have a great day, and we'll see you next time. All right. Take care, everybody.